Welcome to Quiet Learning. In this video, we'll gently follow the path electricity takes to your home, from where it is made, through the networks that guide it, and finally into a home, ending at the moment it reaches a device and begins doing useful work. You don't need to focus on or memorize anything during this video. Just sit back and listen as we move slowly in a simple step-by-step way. Let's begin. Electricity is something most homes use constantly, often without much thought. Lights turn on, appliances hum quietly, and devices charge while we rest. Behind that calm, familiar experience is a long, carefully managed journey. Electricity begins at a place called a generating station. This is where other forms of energy are converted into electrical energy. Many power stations work by spinning something. When a turbine spins inside a magnetic field, electricity is produced. The faster and more steadily it spins, the more electricity can be generated. In some stations, the spinning comes from heat. Fuel is burned to heat water, creating steam. That steam expands and flows past turbine blades, causing them to turn smoothly and continuously. The fuel used can vary. It may be coal, gas, or other combustible materials. The important part of the process is not the fuel itself, but the steady rotation of the turbine. Other generating stations use natural movement instead of fuel. Flowing water can turn turbines in a very similar way. Wind can also rotate turbine blades, which are connected to generators that produce electricity. Although the source of motion is different, the result is the same. A spinning turbine drives a generator, and electrical energy flows out. Solar power works a little differently. Instead of spinning turbines, solar panels use light directly. Inside a solar panel are layers of special materials called semiconductors. When sunlight hits these materials, it transfers energy to tiny charged particles called electrons. Those electrons begin to move. That movement creates an electrical current. The electricity produced by solar panels is direct current, or DC. This type of current flows in one steady direction. Most large power networks use alternating current, or AC, which regularly changes direction. Because of this, solar electricity is usually passed through an inverter. The inverter converts DC electricity into AC electricity, so it can be used by the wider power network and by homes. Once electricity is generated, it begins its journey away from the power station. Electricity is easiest to move over long distances at very high voltages. Higher voltage allows the same amount of power to travel with less energy lost as heat. To achieve this, the electricity first passes through a transformer. This transformer increases the voltage to a very high level. From there, the electricity enters the transmission network. This is the part of the system made up of large towers and thick power lines, often seen crossing open land or following long corridors. These lines are designed to carry large amounts of electricity efficiently. They are spaced far apart and kept high above the ground for safety and insulation. As electricity travels, a small amount of energy is always lost. Some of it becomes heat in the wires, some is lost through electrical resistance. Power systems are designed to reduce these losses as much as possible, but they can never be completely eliminated. This is why careful planning of routes, voltages, and materials matters. Eventually, the electricity reaches a distribution area. Here, it enters a series of substations. A substation is a place where electricity is controlled, protected, and gradually adjusted to safer, lower voltages. Large transformers reduce the voltage step by step, from very high transmission levels down to medium voltages suitable for local networks, and then lower again for neighborhoods. Different types of power lines are used at different stages. Thicker lines usually carry higher voltages. Thinner lines carry less power and serve smaller areas. Some lines are overhead, supported by poles or towers. Others are underground, protected by insulation and conduits. As electricity gets closer to homes, it becomes part of the local distribution network. Eventually, a supply cable branches off towards an individual building. This cable is designed for the voltage and current required by that home. The electricity enters the house at the meter box. The meter box is a control point. It measures how much electricity is used and contains important safety devices. The meter itself records energy consumption over time. This information is used for billing and monitoring. Inside the box are protective components. Fuses or circuit breakers protect the wiring from overloads. If too much current flows, they disconnect the supply to prevent damage or fire. Many homes also have residual current devices, or RCDs. These monitor the balance of electricity flowing into and out of a circuit. If some electricity is leaking where it shouldn't, such as through a damaged cable or a person, the RCD disconnects power very quickly. From the meter box, electricity is divided into circuits. Each circuit supplies a different part of the home. Some circuits are for lighting, others are for power outlets. Larger appliances may have their own dedicated circuits. Different types of cables are used inside homes. They are sized according to how much current they need to carry. Thicker cables handle higher loads. Thinner cables are used where less power is required. Most homes use single-phase power. This means electricity arrives as one alternating voltage waveform. Some larger homes or buildings use three-phase power. In this system, 3 separate waveforms are supplied, each slightly out of step with the others. Three-phase power allows heavy loads to shed more evenly. It's often used for large motors, workshops, or high-demand equipment. All of this wiring is hidden behind walls, ceilings, and floors, quietly waiting, always ready. When you plug a device into a power socket, you complete a path. Electricity flows from the power station, through transmission lines, through substations, through the local network, into the home, through protective devices, along internal wiring, and finally into the appliance. Inside the device, electricity does work. It may produce light, heat, movement, or stored energy. After doing that work, the electricity continues along its circuit, returning safely through the system. This entire process happens almost instantly, but it is carefully controlled at every step. Electricity reaching a home is not sudden or chaotic. It is steady, measured, and guided. A quiet flow, supporting everyday life, without needing attention. And now you can let that understanding rest, knowing the system is doing exactly what it was designed to do. This has been a quiet learning explanation of how electricity gets to your home. If you've enjoyed this step-by-step process description, you might enjoy some of the other quiet learning videos where we examine everyday processes gently. Thank you for listening.